Hello students, welcome to your Data Communication and Computer Network class for 4th Sem IT. In this video, I will explain about multiplexing. After completion of this video, student will able to know about multiplexing and different type of multiplexing like frequency division multiplexing, wave division multiplexing and time division multiplexing. Again, time division multiplexing are of two types, that is synchronous time division multiplexing and asynchronous time division multiplexing. So let's start. First of all, what is multiplexing? Multiplexing is a technique that allows the simultaneous transmission of multiple signals across the single data link. Means a different multiple signal can travel a single data link. And it can be done using a device called multiplexer or MUX. Okay, MUX that combine n input line to generate one output line. Means n input signal are combined to generate a single output line. Means many to one. And at the receiver end, another device is used that is known as demultiplexer or demux. Mux is multiplexer and demultiplexer is used to separate signal into its component signal, that is one input and several output. Means from the sender side, multiple number of signal are combined and generate a single output line that travels in a single data link, and at the receiver end, demultiplexer is used to separate the signal into component signal, means one input and several output is generated. So this is the figure. N input line are combined using MUX multiplexer and generate a single signal and that travel in the single link. And at the receiver end, it use another device that is known as demultiplexer or demux that separate the single signal into its n component signal at the output end. Advantage of multiplexing. More than one signal can be sent over a single medium or link. Means more than one signal, many signal can be sent simultaneously over a single link, and it is the effective use of bandwidth. Okay. So it is no multiplexing. In no multiplexing, we can use n number of channel for n communication. Here 4 link is used to communicate between 4 sender and 4 receiver. But using multiplexing, we can use single link to communicate 4 sender and 4 receiver by the using of multiplexing concept. Next is type of multiplexing. Multiplexing are divided into 3 types. The first one is frequency division multiplexing, then wavelength division multiplexing, then time division multiplexing. Again, time division multiplexing is divided into 2 types. Synchronous time division multiplexing, that is synchronous stdm, and asynchronous time division multiplexing, that is asynchronous stdm. So let us discuss it one by one. First is frequency division multiplexing. Frequency division multiplexing is an analog technique. In frequency division multiplexing or FDM, signal of different frequencies are combined into a composite signal and transmitted on the single link. Means different frequency are combined to form a composite signal, and that composite signal is transmitted in the single link. Bandwidth of the link should be greater than the combined bandwidth of the various channel. Means bandwidth of that link must be greater than the combined bandwidth of the various channel. And each signal is having different frequency. Channels are separated by a strip of unused bandwidth. Means when the different channels of sending different signals, the channels are separated by unused bandwidth that is known as guardband to prevent overlapping. Okay. So this is the example here. Three device and three channels are separated using the gap that is known as guardband. This is the guardband. Okay. Then advantage of FDM and disadvantage of FDM. Frequency division multiplexing is used for analog signal. This process is very simple and easy modulation. A large number of signal can be sent through an FDM simultaneously. It doesn't require any synchronization between sender and receiver. Then disadvantage of FDM. FDM technique is used only when low speed channel are required. Means it can use in low speed channel. It suffer from problem of crosstalk. It require a high bandwidth channel. Then application of FDM. FDM is used for FM and AM radio broadcasting. AM frequency is 530 to 1700 kHz and FM frequency is 88 to 108 MHz. FDM is used in television broadcasting also. So here in frequency division multiplexing, the signal from different sender, frequency of different channel are combined together with multiplexer and it generates a composite signal. This composite signal is travel through a single link and at the receiver end demultiplexer are used to separate the component of the signal. Then the next multiplexing is wave division multiplexing. Wave division is an analog multiplexing technique and it is same as FDM. In wave division multiplexing, different signals are optical or light signal that are transmitted through optical fiber. Main difference is in wave division multiplexing, it uses light signal. Various light waves from different sources are combined to form a composite light signal that is transmitted across the channel to the receiver. Means signal or light signal from different sources are combined to form a composite light signal and that is transmitted across the channel. At the receiver side, this composite light signal is broken into different light waves by the demultiplexer. This combining and splitting of light waves is done by a prism. Prism bends beam of light based on the angle of incident and the frequency of light wave. So this wave division multiplexing work, a different light signal are combined by using multiplexer and then it travel in a single channel. Then at the receiver side, a demultiplexer is used to separate the light signal. Then advantage of WDM, wave division multiplexing. It allows transmission of data into two directions simultaneously and it is very low cost, greater transmission capacity, high security and long distance communication with low signal loss. These are the main advantages of wave division multiplexing. And the last one, that is time division multiplexing. It is a digital multiplexing technique. Channel is not divided on the basis of frequency but on the basis of time. Means in this case the channel is divided in the basis of time, the total time available in the channel, is divided between several users. Each user is allotted a particular time interval, that is time slot or slice. Means every user have its own time slot or time slice to transmit their data. In TDM, the data rate capacity of the data transmission medium should be greater than the data rate required by sending or receiving device. Means the data rate capacity of the medium always should greater than the data rate required by the sending of a receiving device. So this is the example of time division multiplexing. Each user, here in this case there are 4 users, and each user have their own time slot to transmit the data in the channel. And there are 2 types of time division multiplexing, that is synchronous time division multiplexing and asynchronous time division multiplexing. So let us discuss it. First is synchronous time division multiplexing. In stdm, synchronous time division multiplexing, each device is given same time slot to transmit the data over the link whenever the device has any data to transmit or not. Means each device are given some time slot, and if they have data or not, they have allotted the time slot. Each device places the data into the link when its time slot arrives. Each device is given the possession of line turn by turn. Means each device have their time slot and they send their data in the link when their turns come. If any device doesn't have data to send, then its time slot remain empty. Means if there is no data the device have to send, but it have its own time slot and that time slot remain empty. Time slot are organized into frame, and each frame consists of one or more time slot. If there are n sending device, then there will be n slot in a frame. So here in this case there are 5 users and a frame having 5 slot, means each slot for every device. Okay, so each slot for every device, and if the device have no data to send, then this slot remain empty. Then multiplexing process in synchronous time division multiplexing. In stdm, every device is given opportunity to transmit a specific amount of data into the link. Each device gets its turn in fixed order and for fixed amount of time, that is interleaving. Interleaving is done by a character 1 byte. Each frame consists of 4 slots as there are 4 input devices. Means if there are 4 devices, the frame consists of 4 slots. Slot of some device go empty if they do not have any data to send. If there is no data to send, then the slot will send empty. So this is the process of stdm. So if there are data like A, B, C, D, so first frame consists of A, B, C, D, then A, B, C, D. Okay, then second frame have 4 frame, third frame also have 4 frame, but in fourth frame there are data is A. Okay, then second device is no data, so there is empty slot, then C, then D. If there is no data, then the slot will remain empty. So this is synchronous time division multiplexing. And disadvantage of stdm. the channel capacity cannot be fully utilized because some of the slot go empty in certain frame. So this is the main disadvantage of synchronous time division multiplexing. Some of the slot go empty. Then the next is asynchronous time division multiplexing. Asynchronous time division multiplexing is also known as statistical time division multiplexing. In this time slot are not fixed, that is slot are flexible and total speed of input line can be greater than the capacity of the path. In ASTDM we have n input line and m slot, that is m is less than n. Okay. So in synchronous time division multiplexing, always the number of slot is equal to number of input line. But in this case, maybe the slot less than the number of input line. Slot are not predefined, rather slot are allocated to any of the device that has data to send. Means if the device has data to send, then it will allocate with the time slot. If the device has no data to send, then the time slot will not allocated for that device. So here there are 5 input line, but only the three line have data to send. So there will allocate the 3 slot in a frame, and in this case, in some case it have only one channel to have data to send, then it have only one slot. Okay, so it is flexible, the slot are flexible. Here only 4 lines for sending data because this device has no data to send. Here all the device have data to send, so all 5 lines are sending data. So this is all about your asynchronous time division. So this is all about a different type of multiplexing like frequency division multiplexing, then wave division multiplexing and time division multiplexing. Again, time division multiplexing are of two types: synchronous time division multiplexing and asynchronous.